Hey there, hi there, ho there. Welcome to Unit 5. So this is going to now start to get into conversation about the rock cycle and talking about minerals and rocks. We'll mostly talk about minerals in this unit. The lab will be focused on minerals, and then each successive unit will deal with a different type of rock. So, where's my mouse? There we go. So we have been spending pretty much the first 4 units in the tectonic cycle. Now we're going to connect that to the rock cycle. The rock cycle, talking about minerals, talking about igneous rocks, sedimentary rocks, metamorphic rocks, etc. So to start it off, we first need to talk about some small stuff. And when I talk about small stuff, I mean the smallest stuff. So let's talk about atoms. An atom is the smallest individual particle that retains the distinct chemical properties of an element. So, for instance, if I had a chunk of gold, well, that's made up of a bunch of atoms of gold. Each atom is the smallest thing that makes up or has the same characteristics as that property of element as a whole. So whether it's a big bar of gold or a single atom of gold, it's chemically the same thing. It's all the same element. The word atom is kind of interesting. I like breaking down words. Sometimes it helps me to understand what they mean a little bit better. So atom comes from the Greek word atomos, meaning indivisible. The ancient Greeks actually had a kind of a thought experiment. If they took a loaf of bread, cut it in half, took that half, cut it in half, took that half, cut it in half, took that half, cut it in half, keep cutting that half in half, at some point, they're going to get down to the essence of what makes up that bread, something so small it cannot be divided anymore. So that's kind of where this idea came from thousands of years ago. Atoms are made up of protons, neutrons, and electrons. Protons and neutrons in the nucleus, electrons surrounding the nucleus. And it's different numbers of protons that give us all the different elements on the periodic table. I'm not assuming you know anything about the periodic table, you know anything about chemistry, just a little introduction, which will lead into why we have so many different minerals. So, elements is a substance whose atoms all have the same number of protons. So, any atom of hydrogen will always have 1 proton. It's the atomic number, which also indicates the number of protons. Any Au is gold. Any atom of gold will have 79 protons. So elements, these are the chemically the simplest substances. Sometimes they exist in nature all on their own. A lot of times these different elements are combined with other things, and we have to kind of separate those materials if we want to get out certain elements. But different combination of elements gives us the different combination of minerals. So that's why we have to start here with just a little introduction of chemistry. So you take a little bit of, for instance, Na, which is sodium, and you mix it with a little Cl, chlorine. NaCl, you mix those two things together, you get the mineral halite, commonly known as salt. So, yeah, sometimes minerals are just made up of a single element, sometimes they're made up of a combination. In the Earth's crust, of all of these things on the periodic table, up to number 92 naturally occur on Earth. Other than that, they are not naturally occurring. They're typically only made in labs. But up till 92, they do occur on Earth. So, in the Earth's crust, of those 92 elements, what do we have most of? Well, we can actually boil it down to kind of the 12 most abundant elements in the Earth's crust. So the Earth's crust itself is made up of over 45% oxygen atoms. Now, it's not just oxygen on its own, it's oxygen combined with a bunch of different things, but in any case, if we were to tally up all the elements, all the atoms, all the stuff that makes up the crust, oxygen somehow makes up over 45% of that. Silicon comes in second, just over 27%. Then you have aluminum, iron, calcium, magnesium, sodium, potassium, titanium, hydrogen, manganese, phosphorus, and then everything else. So of those 92 naturally occurring elements, 12 of them make up this much. The 80 others only make up a very small percentage of the Earth's crust. So, since, for instance, oxygen and silicon, since these are the most common elements in the Earth's crust, they're very common in minerals. A lot of minerals, and I'll show you some examples, contain oxygen, contain silicon. A decent amount also contain aluminum, iron, maybe calcium, magnesium, sodium, potassium, titanium, hydrogen, manganese, phosphorus. But again, oxygen and silicon we'll find in a lot of minerals. A lot of minerals. For example, the mineral quartz. Quartz is one of the most common minerals in the Earth's crust. Its chemical formula is 1 silicon atom and 2 atoms of oxygen. So SiO2, silicon dioxide. It's quartz. So there you go, silicon, oxygen. Again, quartz is one of the most common minerals in the crust because it's made up of the most common stuff in the crust. Olivine. Sometimes you get these nice little crystals. Sometimes they're microscopic. But in any case, this nice green color, and the olive color, olivine. Made up some of magnesium and iron, but also, again, silicon and oxygen. So again, silicon and oxygen, the two most common elements in the Earth's crust. They're in a lot of, minerals. Garnet, there it again. Silicon, oxygen. Aluminum was 3rd on that list. Iron was 4th on that list. Calcium, I think, was 5th on that list of the 12 most abundant. So again, garnet, another common mineral. Muscovite, which is a type of mica. Here again, silicon, oxygen, more oxygen, potassium, aluminum, which is 3rd on the list, hydrogen. Again, very common stuff, very common mineral. Hematite. Here we go. Iron and oxygen. Hematite. It's a mineral that we pull out of the ground to help extract iron to make steel. Calcite. Calcium on that list. Oxygen on that list. Carbon not so much on that list of material in the Earth's crust, but it does make up a portion of calcite. And then diamond. Diamond is just made up of one element. Carbon. C. That's its chemical formula. That's it. Just C. A bunch of C's together, a bunch of carbon atoms together makes diamonds. Again, carbon not very common in the Earth's crust. Therefore, diamonds aren't very common. Hence, they're so expensive. All right, that's just a brief little introduction about some of the small stuff that makes up minerals. It's different combinations of all those elements gives us the thousands of different minerals we have on Earth. We'll only really touch on a few in this class and in this lecture, some more common minerals. But we'll pause there. When we come back, we'll kind of define what a mineral is and try to understand how we can identify them. I'll see you back here in just a second.